year now.
Okay. Because overall, we kind of, in a large network, we like to keep as many of the smaller remote switches to a minimal as possible. Because what that does is every time it hits a switch, it's another jump between different devices.
Okay.
The longer those jumps become, the more complex those routes become.
Okay.
And a little bit more congested and slower the network becomes.
Okay.
Okay.
So physically wiring speaker, if that thing basically has to be there, what would I do?
Well, it doesn't have to be there because we could put, it really just depends where we want to distribute the network access from. You know, obviously we have, up here we basically have 1 device, 2 device, 3 device.
Right.
Back there we've got your point of sale system, which are going to be multiple devices.
Right, and that's pretty much it. And those other ones won't be there. They'll be around the bar. That's what it is.
Are those already run back here? Or?
They are. What it is this used to be open as a bar, and the physical point of sale system would be there, okay? Those other ones would be
stations.
in different spots,
Yeah.
but they have a whole like little rack where you can plug into, and this will be that bar, that bar, that bar. Does that make sense?
So there's already wiring for that.
Yes, that's what I'm trying to say. Yeah.
So we'd probably distribute from back there then still.
Okay.
But I would want to see probably a couple lines run up here.
Okay.
So for like 1 for each computer, 1 for the node.
From that thing directly.
Yeah.
Not going to a switch and splitting off.
Correct.
Could I have a switch anywhere? You don't like to go a switch after that switch,
No,
basically.
we pretty much want to have 1 switch and every device connects to it directly.
And there's only like eight inputs or something.
No, you can get switches that are massive.
So I would need to replace that wireless switch, which with one that's a lot bigger. That's what you're saying, instead of trying to expand with a sub switch.
Correct.
Okay, that makes sense.
And we can work through that. But so overall, if we did something like that, it would allow us to, and if we go to more of an enterprise grade level switch, we can actually segment sections off. So like all the point of sale system would be on its own little sub network within that.
But
all of our
would they be
AV
physically?
components-
Would it be physically plugged in?
Yes.
Because that was their switch. Not, I mean, like when we got the POS system, you're saying I'd have one cable out of the router, I'm calling it, into their switch, which is the Aloha POS. From there, that would distribute to all the bar POS systems, right?
It would all come into one big switch.
Okay.
So, and the cool thing is that with higher level switches, we can do what's called VLANing or virtual LANs. So we can basically segment different things. So I can make this big, huge switch that say could have up to 48 ports. And I could say have here all the POS stations plugged into it. I can have all my AV network plugged into it. And then we could even have some wireless access points
Plugged into that.
And now what we can basically do is say, okay, this is kind of a little sub network, and it can only communicate with itself.
You're saying with your numbers like 168, blah, blah, blah.
Yeah, IP addresses and that sort of thing.
Okay.
This thing would all be its kind of its own sub network. It talks to all of itself.
It's
And then
little-
these wireless access points we can then develop however we want. So this one of these could be, one would be guest, one would be, production.
Right.
And if you did need, wireless
for
POS
POS,
station, then you would have one that's going to be a wireless network for just the POS that these connect together then.
Gotcha.
So it would allow us to create still one main central network, but divide it up so that everything isn't trying to fight with each other.
Gotcha.
Okay? This is the overall thing. We can make this work and it will work, but
I'm getting what you're
this,
saying.
it's just the POS, you can make that its own secure thing. You've got your AV network, so you're not getting any traffic stomping on each other if they're running a lot of credit card processing and stuff like that. And then, you have different wireless access points for just internet access.
Stupid question. So then, if that was the case, I got this main thing,
Yep.
and for my production, so I would need a wire for that computer, a
And
wire
this
for that
computer,
computer,
and
and
then
then a wire for the ARTNET. So I need basically, I have one, I need 2 more.
Correct.
Unless I have anything else that comes up here. And so
Actually, what I'm going to do is I'm going to reconfigure this just to make it a little bit better for now.
Okay, that sounds fantastic.
And that'll help because what we can basically do is we'll use this to do our wireless,
Okay.
and this will be our switch. We'll eliminate this switch by using this.
Oh, okay.
Okay, so we want to.
I will turn on more lights. Okay, as a quick recap, basically we've plugged things into here and out of the switch. Switch is bad, That's a better way to do it, but ultimately, it's better to get run all the cables I need up here from that switch up to here and plug directly.
What it does is it assigns IP addresses dynamically. So it says, okay, my phone's connected. I need to connect to your network. Okay, great. It assigns me an IP address automatically for me to communicate with.
Okay.
And typically we don't care. A normal device is just for internet. We don't care about what the actual IP address is. But when we have our tablet and we want to connect directly to Chamsys software, we need to know the IP address of where the computer is.
Right.
So that's why we're going to give it a static IP address. Same thing with like our node.
Okay.
We want those things to be static so that the connection's always there.
Okay.
Okay. Right now here it says it's configured using DHCP.
Okay.
We're actually going to choose manual instead. And we're going to assign it 192.168.132.11. And I'm basically, so I'm basically saying use this IP address for this computer.
Okay.
So I went ahead and applied that.
Where'd you get 132 by the chance?
That is what comes from the Amplify router.
Okay,
That
all right.
Amplify wireless
So you're
access
making
point.
it within Amplify. Gotcha.
Yeah, Amplify was basically set to 132. Was its subnet? Was this subnet that it was using? So we'll just continue to use that. When you see router here, this basically is what device is it actually connecting to. So that device is 192.168.132.1.
Okay.
If we were to put this on,
The IP address is this one's IP address.
correct,
Gotcha.
this computer's IP address, and this is the device that it's connecting to or router it's
Gotcha.
connected to.
Helps a ton.
Yep. Now, if we hook this computer physically to that ASUS access point and we wanted to
Right.
give it a static IP address, the IP addresses for that one are in a different range. They're
Gotcha.
192.168.50. something.
Gotcha.
So, but we're going to kind of make this our own little network up here using the Amplify.
Gotcha.
Okay.
Okay, cool.
So we'll do the same thing over here on the PC. Start, settings, and network and internet. And we want to go to this change adapter options.
Okay. That's what I was always looking for. Okay.
So, and we're not going to use the Wi-Fi on this computer.
Right.
So I'm actually going to disable it
Good.
because we're not going to need it because we can connect wirelessly to this, which is already connected to this.
Cool.
So we're going to change properties of the wired network card in here.
Okay.
IP version 4
Okay.
and properties, and you'll see something similar here. Again, it's asking for IP address, so 192.168.132.10, and subnet mask is correct, and 192.168.132.1.
One.
Yep.
I got it right.
Correct. Now, the subnet mask is something else that's very important in network settings. It basically tells us how many IP addresses in this network do we utilize. If we have 255, 255, 255, it basically says we can use the last octet or the last set of numbers.
Okay.
And that basically gives us 255 IP addresses.
Okay.
Okay. If we needed more than 255 devices, we would have to use a different subnet mask to give us a bigger IP range.
Gotcha.
But for your application, I don't think we'll ever extend it past that, so you don't have to worry about it. Okay. So now we got that wired connection set. So let's go to magicq PC under network, and now notice we only see one IP address here.
Yes.
That's because I turned off that other network card,
Gotcha.
the Wi-Fi. Okay, so there's only one network card on this computer, so there's only going to be one IP address associated with this machine.
10, because that's what the static IP.
That's what I set the static IP address
And that's
as.
this thing right here.
That's going to be the static IP address to connect to.
Okay.
Correct. So now we have that set. Now let's go to our node.
Setting this cheap V show is, we were just setting it to, same thing, 192.168. Shit, I read the other number. But
132.
yeah, 132, and then we're gonna use which one? 20, right?
Yep.
Okay.
It's our internet access.
Okay.
And now we've connected all of our computers here to this
Internet
point.
access is from here to there, and everything else is all connected to there.
And then that gives you your distributed Wi-Fi network as well.
No switch to simplify.
Yep. So now if you want to connect your tablet, you're going to want to connect to the Boom Boom Room mesh wireless.
Okay. Just to talk about that, gateway address right there, which is the router, which is that one.
Yep.
That's what that is. Okay.
All right. So